Hi, it has been 2 weeks that we haven't seen each other. I hope you have a great Mid-Autumn Festival, have enough mooncake, but not too much. Still awake to learn what we're supposed to learn today. The goal of today is to, of course, finish our lesson two material, and we reach to lesson three, but we first finish lesson two first. And um, since there have been 2 weeks time, so probably we will take some time to move a little bit. And of course, you may be aware that we are slightly behind the schedule, but I think that's okay since we are catering all of you. I mean, in the case that the two classes are not having the same speed, which the other class is a little bit faster, I will do the lowest common, highest common factor, which means I'll take whatever the intercept. I mean, put everything in the test. So don't worry about that. If you are slower or faster, uh, doesn't really matter anyway. The exam is same across the two sections, and just don't worry about that. In any case, and probably you might have seen in the Blackboard that I have uploaded the quiz. Okay, so as long as you do it, you will get the credit for that. I mean, as long as you finish it, you get the full credit. 3 point of CA, but the maximum you get is 10 anyway. So I mean, at the end there will be five quizzes. Each two classes we have one quiz, but the quiz, I think if you do 3 or 4, you do 4 of them is already above the maximum. But anyway, we give at most 10. But if you do it, you get 3. So that would be okay. Okay, as long as if you do all the question. Okay, but if you don't do all the question, you just go there and submit, then you get uh, uh, no credit. Okay, you have to attempt all the question. Okay. So have to count whether you attempt all the question. Okay, and there's no whether you get it or not. Okay. Okay. The assignment I'm making, but I will try to make sure that I don't give you too many assignments. So I just maybe combining 3 or 4 chapters, make one assignment, make it more comprehensive and slightly a little bit more challenging, but shouldn't be too difficult to do. Maybe more or less asking you to use the Python to create something. Probably ask you to submit your work in a code lab and then just send a link to the TA. TA will check. But that would be the goal. So now let us continue. But as I said, since it's been 2 weeks time, so let's quickly review what we have done so far. So the lesson 2 is trying to give you the idea of how to summarize the data, right? Using some numbers or some graphs, focus on one particular variable or measurement. And the chapter 4 is trying to look at how 2 different types of measurement are related, right? That is the beginning point of cause and effect, right? So just to remind you how we draw the table, right? If you still remember how we do it, is we have the URL and the pandas with CSV, right? And then we would, because we focus on a particular type of data, we will filter first. Okay, filter the data which focus on hotel. And then there are 2 variables we want to look at: the price and the distance. Of course, you look at others, right? Here, look at the price, and then we have to draw the histogram that have to tell the bean how big is the group, because histogram means you group the data, right? And then by 1, actually don't group anything, but that's a Python idea, right? And that's the diagram you drawn, and then you can also draw it the other way around. Is the little bit different the distance, and also you can have a type of graph, right? And you also can filter a little bit. Oh, those of you who see the slide, the slight minor changes, but otherwise same slide, because some of you, I think, told me that I should include the output of the Python code, try to. So that's I just make some minor amendment. If you have used the old slide, there's no difference. Okay, maybe I add one or two slides, but there's no changes to the existing. Okay, in case you worry about whether I add something new there, there's nothing new, but maybe one or two slides add something new, but this should be fine. And we also talk about, look at the graph, is histogram, but also we can look at the case where look at the summary statistics, right? And the bunch of stuff there, okay? And okay. And we also look at how to collect all the data there, okay? And we talk about how to merge data, right? I think if you still remember our code here, right? We learn, if you still remember this, we do combine two data sets using the merge, because the price data is for the same ID with different days data, right? But this price data doesn't have the feature of the hotel, which come from the other feature data set. And you have to combine, you combine on the left because it's one many to one, right? So that's why on the left. And this left and right actually follow the SQL language, if you know what SQL is, but otherwise it doesn't really matter, but just the way they talk about how to combine database. And then we talk about the density plot, okay? And I think we somewhere stop here somewhat, but in particular, I add one slide because in the other section, I actually challenge them to say, why don't you, because some of the students asked me, how do I plot this? And I said, okay, well, you go home and do it. And then some people are successful, some people are not, so ask me how to do it. So, okay, fine, I just include it in here. So, but this would be how I do it. So the Matplotlib is a package that is very fundamental to the drawing. It's the base. This a drawing package that is allow you to draw a lot of stuff. If you have provide a lot of code, and there's a front end library which actually also add on to the Matplotlib. Okay, and that's called the Seaborn. The Seaborn, which is like a package that would help you to make your code simple. Okay, you see the Matplotlib is a little bit, you write a lot to draw. But when we're lazy, then you don't want to do it. One way to do it is use the Seaborn. Then you can use the KD. KD is a density plot. You just call it, then you can draw. Okay, so let me copy this line and run it because this is something that you can. So I just run this code, which you have seen is combining the price data. Wait a little bit because I think it's running. Okay. It's combined data set because it's I think it's a 20,000. So that's why download requires some time. It's up to here now. Now it's done. And then there's the data, and I just keep going on. I combine the data set here. Okay. I take away what we have done. And I cut out the data. Okay. And I call this V price because I want to draw the thing or V price, the Vienna price. Okay. And same thing here. And I cut for London, I call L price. Okay. once I did that, then sorry, I now pricing. Okay, this is London, this is Vienna. Okay. And what I do now is to plot this thing, and I do remind you that this SNS is the seaborne, which is the package that enable you to draw matplotlib more efficiently. Okay, that is the code. So once I do that, let me do one by one because you can run together. The good thing is they will superimpose. You can see they would tell you this is actually, by guessing, you know this is Vienna and this is London, right? Then they can compare. So that would be the way you would draw. Okay. Is that okay? So this is something that I was trying to ask the other class by making them a small little homework, but they seems to not, some of them doesn't do it very well. So that's why I just put it there. So this is how you draw them before. But you can look at the seaborne package. They also have a lot of, but I think you can just check it by yourself. But you can see the gallery that many plot. But the underlying, they are using matplotlib. Okay, but this is, you can draw a lot of, say, this plot like this. This is commonly you have seen, and I think there's too many examples here you can draw. But do note that this is a front end for the matplotlib. Okay, so that's why it's not, it doesn't include every single graph you can draw, but it's a convenient when you try to draw because it contains most of the thing you want to draw. Okay, and the code is much simple because it's tailor-made, right? It's just like custom-made. Okay. So we have some descriptive statistics. Okay, here. Okay. You can beside the diagram also you get the data, right? The mean of London is higher, median is higher, deviation is higher, right? So that's why, and London has more skew, then basically the number actually also give you the idea of the same graph, right? You can actually, even though if you can not see it, but by looking at the numbers, look at the mean, look at the standard deviation of skew, then you can much guess what's going on there, right? Because look at the graph again, right? London, right, has higher mean, more variance, right? There's more skew because center is here, is more thing on the end, right? So even look at the graph, you will see it's consistent with the table, right? But of course, the graph doesn't tell you the end, right? You can see the max and mean might be okay, right? Median is not that easy though, but you can look at median is the middle, right? So median can also see is like looking at London is somewhere here, area left and right the same, right? That's what the median is, right? The middle 50%, and same as the Vienna, right? 50%. So should be able to see those. And just a final remark on the graph, right? How you draw the good graph, right? So as I said, if you want to present business setting, then how to draw a good graph and good table will be very useful. But of course, if you are a beginner, it's very difficult to know what's good, what's bad. The easiest is to just copy how good things being done, right? You look at other good report, how do they draw the graph, how do they present the table, and just copy, right? The format, right? I mean, the format has no copyright, so you can copy the format, right? You can just copy, right? Just like how master of comic draw comics, right? You look at people, say how they learn drawing or painting, right? Just follow someone's style, and after copying enough, then you have your own style. So same goes on here. If you don't know how to have a good table or good graph, look at textbook, look at other publication, and then see what is good. Okay, then that would be the way to go. But I'm not going to go to every single detail what's going on here and there. But okay. So let's go to chapter 4. I mean, that is something that I think we stop somewhere here. if I'm not mistaken, right? And so just to remind you, what we're doing is we want to do two things. Actually, this is the goal of the rest of our course. Okay, the first goal is to do prediction. That is the idea of running regression, running the machine learning models. This is something, or time series model. These are the things we predict. We are not trying to attempt to understand the logic behind, but trying to see or predict what's going on there. It's not trying to explain. We are not trying to discover whether X caused Y, but rather X and Y. You see this X, this is the Y. Okay, of course, this is one step before you can do causality, right? To extrapolate causality, whether you take this action will lead to this, require more than the data. You need to have some knowledge about how the data being generated, make some assumption how the data generation process behind. There's some clever tricks you can do it. Okay, just like when you do things in experiment in the lab, right? You change one thing at a time, then this is clearly can demonstrate the causality, right? But if you can't control, you have to change multiple things at the same time, then you need more stuff. Make some assumption or we have some theory behind, then that can help us. Okay, but that would be the goal of the last two topics. But the main thing we do prediction. Okay, there's no attempt to do causality, but how they covariate. And but main thing is the goal of prediction is conditioning, right? It's given X, what is expected value of Y? I mean, that's basically the regression idea, right? But the first step is involving that we would do a scatter plot or a bar chart to see, visualize this relationship first, okay? And later we talk about regression or other machine learning methods, okay? So we will go back to the data. We do the class one, we have talked about the management scores around the world, right? So look at why some country have better management score, why some country have more profitable data. I'm not going to download that because we've seen it already. So the data is basically you have 18 different score for the management, and each category we have 1 to 5, right? So basically each firm would have 18 columns. Each column is either 1, 2, 3, or 5, and the management score is average of 18. Okay, but later we focus on particular one. Okay, and we focus on the data where Mexico 2013, and we want to focus on not too big firm, not too small firm. Okay, which we will do the filtering. Okay, we filter the country, we filter the year, filter the employment, the firm size. Okay, that's what we do. Down data. Data consists of so many things, but we filter that. But you know how to do filtering. Hopefully now you still remember what we do before the Mooncake Festival. But let's see. So this is the histogram. I hope you still know how to. We will see how to do it, but you're able to plot it, right? With the data. Okay. And the score, it looks like this. It's like a bell curve, somewhat. Looks a healthy one. And the data is like a lot of firms. Some firms are large, but at least 20% of them are small firms, right? So when we start with 100 to 5,000, then you just cut off the small firms. Okay, that makes sense because management, if only 5 people, then what's the management score means, right? Just 5 or 2 people or 10 people, right? If 2 people firm, I mean, it's a couples firm, right? Then I don't know who manage who, right? But anyway, it's hard to say, right? So whatever. Now let's look at data. Okay, again, lumpy and panda. Probably you know very well. Let's do that, right? Now data. Let's do that. Okay, very quickly. Nothing new here. I just copy and paste and just do that part because I think you know very well. Okay. Again, when we start, I would start with now with chapter 4. Okay, we have English cookie. So I would just stop 10 seconds in case you are opening the file and copy with me. There it was. Yes. So with download there, then probably you want to look at what's going on, then you just add df.head. Okay, so you should be able to do that. I give you 5 more seconds, and then we go to the next slide. I hope now you should be able to understand every single line of code. If you're not, then raise your hand. Make sure that you understand, because our class is not, it's more a hand-on exercise on the Python, how to apply Python on data analysis, right? And then we try to understand logic behind, all right? But okay, I hope that's okay. If there's no problem, then we go to the next slide. So I think the next one also is not somewhat too difficult. It's a filtering. The filtering, the way I do is LOC, right? So basically, it's a logical operation here. I try to apply the data and see whether the Mexico, the year, the size of firm, okay? And you do look that I don't have the employment, not NA. The reason is being that if this survey, I mean, each firm should have employee, right? There's no firm, there's no one, right? So that's not there's no NA in the data. Okay, of course you can add that, there's no difference. Okay, so that's why we didn't do that. Okay, that's basically, we're basically filtering the data. But let me do that. Okay. So you can look at this data. We have how many data we have. Look at question. Look at the variable. The data tell us this DF have around 14,000 data points. Okay. Now after the filtering, okay, 14,000, and see how many observation we still left. 300. Okay, after the filtering. Okay, you should be able to see that. Okay, so we have 300 data point by filtering. Okay, so what is that? Okay, in case you are still working on, but that would be the idea. Just wait 10 more seconds before we continue. Just make sure that everyone is on the same page. You know how to do it, because of course, for those who are expert in Python, I'm sorry, but let's make sure everyone on the same page. So I just a little bit slower. So the wave means at the time they do the survey, because I think they do it every 2 or 5 years. So that's why they don't do it every single year. So that's why the wave is a year. Okay, its employment of the firm is more than 100 or less than 5,000. Okay, that's a meaning. Now the first thing to do, of course, is to draw a histogram, as I said, right? Because look at data, I want to look at how the firm is about, right? I want to check the data, whether the score is a skew or a nice shape. I invoke the library matplotlib. As I said, this is the most fundamental drawing diagram one of. And if you want, you can do the C-bond. That is a little bit help you to make the code more simple. But this is the one that is more fundamental. And here I just care about the management score. And I set the bin of 1 up to 5, and I put 0.25. The reason being that I only care about the because the average, so that's why there's a decimal places, okay, instead of 1, and then histogram, and then so on and so forth. So MP range is creating a bunch of number between 1 to 5. No, I think I should be more careful. Maybe that's, I think it still should be 5. Which is 5. 1 to 5 is 5. Okay. So no, I think I should do that. I think there's some typo in the slide. Okay. Let me check if that's the case. Yes. I think I need to add this to here to make sure that this is all right. Because the way that MP range is being done. So instead of 5, I have 5.25 because it's the way that how Python define the range. You should add the last one as well. And this is a graph you would have, right? This is the average management score. And this would be same as the one that you should have seen here. Okay. So just make sure that this is 5.25 because that's the way the Python is being done. So the last one have to add the width again. Don't ask me why, but that have to be done in this way. And the next thing to do is we will see the management score, mean, median, and standard deviation. Okay. And one particular way to do it is I didn't show it here, but you can do the describe, which I didn't use it last time. Is when you have a data that is a Python data set or Python series, then you say doc describe would give you the basic summary statistics, the mean, the SD, the max, and the mean. So that would be convenient rather than you can, of course, you can use the doc mean, doc STD. That's all the same thing, right? But that would be easy to do. And then you can do the firm size as well, but I'm not going to do it. I mean, if you want, you can check out this one, right? It's the employments underscore firm. You can do that as well. Okay. And if you want to do that, this is the way to do it. You can do np.mean score and so on and so forth. Okay, you can do that if you want to. Now, what we want to do, okay, for the rest is we will try to understand how management score related to firm size. Okay, and natural thinking will be thinking, okay, if the firm is big, okay, then its management score should be higher, right? There are two possible explanations for this. One, a small firm is good, is have good management, then we expand. So those firms actually big have a good management score, right? And reversely, if big firm is not good, then they will shrink. Okay, that will be one possible explanation, right? This, right, is the management score cause the firm size, right? But the other way around is possible. If the firm is big, the economy scale, they can afford to have good management, right? So it's unclear the causality went which way. But our two story actually tell us that they should be going the same direction, right? Of course, you can basically do a correlation coefficient and you can just done, right? That would be easiest to do, right? You can plot the scatter plot and see what's going on. But what we're trying to do is to have a little bit slightly a different analysis. Is instead of looking at the firm's size directly, we would divide firms into 3 different groups. And we see different group size actually lead to different management score. Why do you want to do that? One, why you want to group things together? Because you want to reduce the idiosyncrasy. It means that I want to, each single firm may have different characteristics. By grouping together, averaging out those kind of firm-specific elements, Okay, that's often used in the study, right? You don't want to say the proposal of you're looking at big data set, right? You're IT manager, right? Instead of looking at each individual customer, you may want to group your customer into, say, age group, by location, right? By city. Look at how they respond, right? Maybe look at north and south, big city and small city, coastal area, inland area, right? Age group, then that can help you to have a much more better understanding there, right? Grouping is very useful because you may not even care about individual, but you care about as a group because you want to say have a business decision based on the group. Okay, so that's why you group. Okay, so now we have a grouping, and don't ask me how they come up with this grouping, but turn out they would. Anyway, interesting is the smallest firm is 1/4, the bigger firm is 1/4, and the medium one is half of that, right? So the course probably ask why don't I have 4 groups and 5 groups, but anyway, I just follow the book. This is what they said. There are 3 groups, and then they pick half of them is the middle, and then 1/4 is small, 1/4 is large. I bet that they try many different type of grouping. This one turned out to be the most easier to see, then they put this one. Okay. And they focus on one thing is the lean management score. Basically telling is it very fat management or good management? It's like lean is like something is not bureaucratic. Okay. So the 5 score 1 to 5, but because it's a raw score. So there's no decamon, it's either 1 or 2 or 3 or 4 or 5. So discrete. So first thing they do is look at the average score within the group in terms of the lean management score, right? So average of 72, the average score is 2.64, the average of medium is 2.68, the big one is 3.18. It seems to tell us that actually as expect, larger firm has a better score. That might be, but we have to have this is somewhat convincing thing, but we want to do it better. Look at more, right? Because the first step, right? Remember, if you have to tell one thing, mean, right? But if you don't want to tell that, then you want to graph it, right? To convince your boss. So look at the graph, okay? We will do a step bar chart. At the end, look like this one, okay? This is the first thing you show the number here. It's a good one. You can convince people. The second, look at this one. You can actually draw it, but I'm not going to do it. But we prepared data to draw it, but we are not going to draw this one. But you can easily draw this one. I left it for exercise for you if you want to challenge yourself. But we'll create a data that actually represent that. Okay, how to draw it is your own fun. I mean, of course, if some of you complain again, I'll add them back. But I left some challenge for you if you want to. Okay, so you can look at this as divided into 3 groups, okay, and different colors. And you can seem to see that under this relative frequency diagram, right? You can see the main problem is many of the small companies actually not very lean, right? But the large company have score 5, right? So that's why you can see this is reducing, the low score is reducing, the better score is increasing, right? So it seems to suggest that the right approach is they are related, right? Of course, by even drawing this, I cannot tell whether is large or small firm lead to different score or different score lead to the size. I have said already. Okay, it doesn't tell you anything about which cause to which, right? But of course, you can reverse the order, right? Of this, you can say 5 different number and look at the size, right? Also, you can let's say you can draw this kind of diagram as well because there's no causality here, right? But I think our eye is easier to see when only 3 category. That's why I think that's the reason why they're 3 instead of 4 category. Okay. So now actually what we are going to do is to prepare the data to draw that one. Okay. We're not going to draw that, but we have a table or number that actually mirror what we have. So what we have is we are going to tell you the code that able to generate categorical variable that based on numerical one. Okay. So what we're going to do is use an MP where. Okay. It's more like the if statement. Okay. is looking at the employment of the firm. If it's less than 100, sorry, less than 200, I give 1. Okay, because 199 is 100 to 199 is small. Okay, we give 1. Okay, otherwise with MP.NAN is not available. Okay, why I do that is everything is below 200, I give 1. Otherwise, I give NA. Okay, don't worry, I will fill up the NA later, but that's the first line. The second line will be fill up things in the middle. For the firm that is between 200 and 1,000, I will put the number 2 there. Okay, if it's not the case, I put what we had before. So that's why I put what we had before. Okay, so that is coming from the first line. The first line said less than 100 is 1. Otherwise NA, right? So what after the second line of code means that if the firm is below 200, it will get value of 1. If the firm is between 200 to 1,000, you get the value of 2. If more than 1,000 is NA. Okay, so the last line of code actually fill up the everything. More than 1,000 is free. Otherwise, we go back to what we have assigned. So basically, what after running this 3 line of code, less than 200 is 1, less 200 and 1,000 is 2, otherwise it's 3. Okay, so it's do it one by one. It's the same as we do Excel. It's the same idea. If you ever have Excel to do the if statement, they're the same. Okay, so of course, maybe there are smart way, but this is the way I do. I mean, those of you who are doing better in programming can think of a smart way to do, but this is how I do. Or actually, this what the book suggests, so that's why I do it this one. Oh, sorry, I haven't defined things yet, right? Oh, I forgot to run this line. I forgot to run this line. And define again. Okay, it's complaining, but anyway, let's see. Let's see, we have the thing we want. Okay, still fine. There's no problem, although he's complaining. Okay. So he's complaining, but anyway, let's still work. Okay. Don't ask me why I use this code, because this code is using the book. So I just try to make sure you read the code from the book, then you'll be easier to read. Okay. And what we do next is to take out the column that we need, which is the number we define, big 1, 2, or 3, small, big, or large. I look at the management score, lean 1. Okay. That's what we do, pick up the column. And then what we do, right, is to calculate the relative frequency, right? Because remember how we draw this diagram is relative to the group, right? Because not each group does not have the same number of firms. So the first thing to do, we need to calculate how many firms within the same group. Then we can calculate the relative frequency. So what I'm going to do is I need to count how many firms within the same group have the score 1, 2, 3, 4, 5, right? So let me run this code, and then you will see what actually I produced. Then you understand what's going on here. There's a slight complication, what's going on, okay? So I hope this filter, you know what's going on, and just pick up. Maybe I just run this first, in case you forget what's going on. Let me run this, okay? I run this This is basically, I just keep these two numbers. Okay. Just put this. This is the firm ID, right? And the next line here is I try to group things, okay, based on the firm size and the score, right? Because score on 1, 2, 3, or 5. Okay. That means for each size of the company and each type of the score they get, I calculate how many of them. And I do the reset index because of the way the Python do is to group them, then you do multi-index because you use multi-index. And I take it away, then it becomes single index. Okay. That will be like this. Then maybe I df one. Okay. It will be like this one. Okay. You give you for each possible firm what under all the lean score, how many firms are there. Oh, there's some doesn't seem to be right. Let me see. Let me run again. So you can tell us for a very small firm, right? The smallest firm, score of 1, we have 14 of them. Score of 1, it's a small firm, score of 2 is 27, right? All the counting. So for those who are curious what the reset index do, you can just comment out and run it again. You have a multi-index like this, okay? It's like this and this, and looks very weird, okay? So that's why doesn't seem to be. Oh, sorry. If you run that, it will be like this. Okay. So this multiple index, it's good for display, but it's not good for our purpose when we draw. So that's why we have reset to make sure that instead of this layered index, but we just make sure one is copied everywhere. So that is the reset index too. Okay. So so let me run it again. Okay. So this is data. Okay. Is that okay? I hope you are able to get this one. In case you're not, just make sure that I just wait 10 seconds before we go to the next slide. Okay. So once we have that, we only need 1 or 2 more steps here. Okay. Is to calculate the relative frequency. So we have to calculate the how many firms within the same group, because we calculate average within the firm size. So what we're going to do is we need to group by the firm size, right? And then look at the count. For each group, we add up all the count. Count is the number that we did here. Okay, because look at the counting. Okay, count all of them, because look at this. The count is this column. Okay, count is the column that we calculate how many of them. Okay, and what we do is looking at this count here, right? We group by this. Say we group by the first column. So we look at small firm. Okay, we add up all this number. So we first thing to do is look at small firm, add together, this will be the thing we do. Okay, we add up the first 4 rows, the last column. Okay, and then add up this number here. Okay, that is what it's doing. And I want the sum of them, right? Because add up all the things, that's how I do. Okay, so let's look at this. Okay. This one, again, what's doing is grouping by firm size. Okay, look at the last column. Okay, I add them up. Okay, so if you do that, you will see 72 is adding up the count here, right? And 72 here is adding up all the last column here, and 155 is adding up all the count in this 4 to 8. Okay, I stop a little bit, and then you can try to make sure that you understand what the code is doing. I don't want to go too fast. So you learn the new thing is dot transform, and I use the sum of all of them. And it's very common, right? Do the summation of them. You can do product, you can do mean, you can do a lot of function, because average, you can average all thing out. You can have fun with this function. Transform is to apply a function on that and to create a new one. Okay. Is that okay? So you can see immediately, if you want to get the relative frequency, you need to divide this over this guy. Right? So we define percent is count over group count. Then this is the percentage we want. Right? So let's run this line. BF1. So you will see that's what we have. All the percentages here. All right. So this, if you're able to look at the menu of Seaborn or other package, then you can draw the stack diagram, right? Because that is how you can draw the stack diagram, right? Stack together. Which I think you have fun if you want to do it. Is that okay? So that is the first thing we do is to create the data that based on what the start from beginning, you filter it and you count how many of them and you draw the relative frequency, right? But even without looking at the graph or look at the data itself, right? You will see for small firm, right? Many of them actually score 1 to 3, right? And only have 11% that is score 4, right? And when you have medium size, right, there's some score of 5, and many of them are score 3 and score 4, right? So on, you can see that already. Okay, already, even though without the data. Is that okay so far? Is that okay? Okay. Maybe I should break here first because I think we need 10 more minutes to continue because I want to draw the stat diagram. What I do later after the break, we'll declare them categorical variable and then replace the prefault and we will do a stack diagram. But we'll do it after break. Okay. Let's have a break of say 10 minutes time, I guess. 15 minutes time. Let me do a short survey, okay, in case you want to tell me it's too fast or too slow, but you have some idea of how to operate the Python. Okay. So let's see your response. See if I'm too slow or too fast, or you need some clarification from me. Okay. So sleepy. Oh, hopefully you're doing some Python, not that sleepy. But I can see why can be sleepy. I can't find the first assignment. Let's see. Oh, the assignment is not given yet. Only the quiz that is you doing for yourself fun. Not self-fun, but it's count as you attempt, you get the credit. Attempt of the question. The assignment will be released maybe after we finish the 3 set of slides. Probably give one assignment. The assignment should be done in an hour or so. Just some, I think I will just do some Python. I haven't finished the assignment yet, but probably with just some Python code. Make you work out some Python. Because the first few chapters is so simple, so I would not just focus on Python. When will be released? You release after we finish the first set of slide. Yeah. So this statement, someone said the course is fun, but someone said it's sleepy. So which I should believe? I don't know. But I do remember a passage. There's a guy in 2000s ago, right? And he go out. Everyone said he's handsome, and his wife said he's handsome. His mistress said he's handsome. His subordinate said he's handsome, and then he understand that. I mean, the real fact is he's not as handsome as the other guy, right? He understand. I mean, when you say something is you don't know whether the truth is, right? I mean, probably you know that, right? You know the story. Oh, thank you. Yeah, well, that's nice. What's QAQ? Is it sad? Happy is no, is it crying? Oh, I'm sorry about that. Okay, so far it's okay. Yeah, but this is very symmetric. This is an example of symmetric distribution, right? At 48, 1, 1, 0, 0 is a very nice one. It's so if you later you learn this unbiased estimate, right? 无偏差 is on average is right. So the collective wisdom is correct. Okay, so that is what we have right here. Oh, it's raining? No, it's very bright. So it should be sunny, but now, right? So probably you should look carefully, but anyway, that's fine. So comparison, correlation, concept data filter, yes. How to change right table, yeah. Group AGG, yeah. Difficult to tell data frame or array. Yes. So that's why when we import the data from Panda, it's always Panda database data frame. So array is a raw data structure used in Python, but for our purpose, you always convert to the Python, the pandas data frame, then can do a lot of nice property. But it's the same, you can say similar thing. But basically you give each column you give different name because of array. That means that if I understand correctly, that will be every entry is the same type, but data frame allow each column of different. So that's why it's slightly different, right? Because it's more versatile data structure, right? Because array only allow numbers, right? But data frame allow each column is different data type. It can be number, can be text, can be integer. Look at that, can be anything, right? So it's more complicated. Seaborn. Oh, the key point is QAQ. Okay, good. Yeah, drawing beautiful diagram is not easy. So that's why actually there's a job. It's data visualizer. Basically, you give the table to them, they will just make it beautiful. And that's a job there. People who do Adobe Illustrator, actually, the main job is to do illustration. So, of course, you're IT manager, so probably you are not, don't worry about that. You just have a nice diagram and just throw it to that guy and he will come back with a very nice diagram. Okay, actually, some people in India just focus on this. And you look at the people who work in the consultant firm, they will use PowerPoint to draw a very ugly table and send it to India. India will come back with a very nice diagram. So that may, that bar chart, we'll do it now. After that, don't worry. Group by AGG, yeah. Yeah, so far it's okay, but I still have 8 people who I'm saying too fast, I guess. The speed is okay. I mean, although it's slower than I would expect, but I think it's good to slow down and make sure that you would do it. So someone also comment on the white because white shirt, because last time you said I always wear the red one. Happened to be, and then okay, I just figured out, and I figured out that only white and red in my cabinet. Okay, I pick up the white one, so make sure that you feel some diversity. My daughter also said white is better, but anyway, white is difficult to, it's easy to get dirty, but anyway. Okay, that's fine. Yes, we go to B.A lab. Actually, they also said the B.A lab is easier for you to get in and get out. So we try to book as many B.A lab as possible. And actually, the program, if you look at this, is actually we have more B.A lab. We have 2 more. If you look at it, we change it to, we get 2 more. In addition to October 9th or October 16th, October 23, we also can do it. And hopefully we can try to book the rest in the B.A lab so we don't have to come up all the way. But I don't know because it's not booked by me. And then hopefully we can do there. But I don't know whether I enjoy here or there. Okay. Here is probably better for interaction because the lecture theater is, I can see everyone and everyone can respond. But in that lab, probably people are separated by a screen, somewhat the screen be in front of you, and you feel very happy to play around with your computer. But hopefully, yes. I don't know, very profitable to play poker card, but it's very profitable to be the casino owner. there. But if you learn probability, then you should think that this is not profitable because the game is biased against you, right? In the long run, you lose money. Suppose you keep gambling because of the bet is not fair, it's not fair bet. So if you do long enough, then you lose money for sure. Of course, if you have self-control, you win and you exit, yes, that is possible. And also there is probably, there's a almost sure you win strategy, right? It's the doubling bet, doubling wager strategy, right? You bet $1. If you win, you $1 go. And then if you lose, you bet $2, right? And then if you win, then you win $2, but you lose the first dollar, right? So you always win $1. If you lose, you bet $4 and so on and so forth, right? You always win $1, right? This strategy never lose, right? Unless if you have enough money, then you can always win, right? You always win $1. You can repeat this process, right? Then you can win. If you go to casino, you notice that this strategy doesn't work. Anyone knows? That's we call it strategy, right? You bet $1, right? If you win $1, right? You get out, and you always win $1, right? If you lose, you bet $2, right? You win, you get $4, but you have to pay. You lose the first dollar, right? So you always win $1, right? So the fourth time you have lost $3 already. So if you win, you still win $1 anyway, right? So you keep winning $1 no matter what you do. So what prevents you to adopt this strategy in the real casino setting is they have upper limit. So I think depends on the VIP room or normal decks, they have a 1,000 upper limit. They have 10,000 or 1 million upper limit. Otherwise, if you keep doing this, you can always win, right? As long as you are good enough, right? Actually, there are some people like this. I mean, they have very good self-control. They keep betting this, then they can win. And there's a lot of people paying blackjack, which is more than 1/2 probability because of if you can remember, you can win. Okay, but anyway, I'm not suggesting you do casino, but since this is a statistic probability class, so I mentioned this as a winning strategy. What is good OOTD? What? Out today? Sorry? Oh, thank you. Any recommended place to go on National Day? I do want to recommend is, I don't know whether to try, but you can try to walk from here to Sai Kung to eat seafood. That is a wonderful walk. You can try to do that. It takes 3 and 4 hour walk from here all the way to Sai Kung. It's a good fun. Oh, man. So something I recommend is here is what we are. You can walk up to here, and there are more than 10 ways to walk to Sai Kung. You can walk across this Mount San Country Park and walk to here, and Sai Kung and can eat seafood. It's a good fun here. It's a good choice here. There's a lot of fun. I mean, I recommend you try it if you haven't do it. It's a good walk. I tried it with friends from overseas. It's a good fun. They can try walk on this one. And if you don't like this 3-hour walk, then I would recommend you try the walk on the Hong Kong Island. Okay, if you haven't been to the peak, you can take all the way to the Israel to Central, or to Admiralty, right? And then one more to Central, and then take the tram all the way to the Peak Tower. Okay, Peak Tower, this one. And then you can walk to this guy. This is a wonderful place where you can see the whole Hong Kong very nicely. It would take an hour something to get there. So that's why I recommend, because I have been there, so I not this recommend to do, and then you can see the whole Hong Kong, and especially a little bit middle of the autumn, so it's a good one. And of course, if you more exotic island, then probably you can go to the Lama Island. Changzhou is also very fun. And these are the things that is more local people would like. Or you can try the repulse, the Stanley. Stanley also good. Stanley, the very old thing there, but or the Repulse Bay, but otherwise other place you can go anytime. But you're probably in the time there where it's autumn or fall, that's a good place to go. I mean, I do recommend that because as IT manager, often sit in front of the computer that make your body doesn't in a good shape. So have a good walk if you want to have fun. Of course, one thing to do, right? Look at the flag going up. Go to the I don't know if you are really nationalistic, right? Then you're going to go to the Golden behind a square, but probably you can't go there because you are not part of the elite. You can't go there, right? It's only restricted to rich people and elite. You cannot see the flag rising ceremony unless you have the ticket. But I think you can do the flag ceremony here in CHK. I think they welcome you to look at the flag going up. Okay, if you want to do it. But I don't know. I mean, so quiz 1 is here. Quiz 1 is here. Quiz 1 is at the end of the here. Quiz 1. Oh, it's hidden from student. Oh, later we put there. Later we put there. I think I will put it on after I finish this slide. Maybe Friday I put it on. Okay. Sorry, I didn't. It's hidden from student, so it will be there because the TA haven't released it yet. Yeah, I think that's so far it's fine. So now go back to here. The first thing we do is we want to declare this is categorical variable. Okay, and to do it is dot categorical, and I define a category, sort them. Okay, and set of it because set means that I only take the non-duplicate, right? Because 1, 2, 3, 4, 5, I just look at the non-duplicate one. And I sort them up from small to big, and I don't reverse it, okay? And this is the thing we do. Let's run it, then you will see what's going on here, okay? Yeah, df1. So you can see that nothing happened, but this already become categorical, okay? So you can see nothing happened when I run this line, but implicitly, the data inside the code will become categorical, okay? By categorical actually means that the number in the data is not a number, that's category. So forbid you to do addition subtraction, okay? So that is the main purpose of that. Otherwise, you don't need to worry about the declaration of that. Okay? Now, once I decide category, then I can do the following thing first. I want to no longer have my head 1, 2, 3. I want to call small, big, or large to make our life easier. That's what I do. That's the first line doing. I replace 1 is called small, 2 is called medium, 3 is called large. I can do it because of categorical data. Okay. Once I do that, I want to pitfall the table. Okay. And why I want to do that? Let me run it, then you will see. Okay. Let's see what we get after pitfall thing. Okay. Oh, I forgot the bracket here. So once I do that, because I want this pivot table is large, small, and big, and the percentage for each category, okay? Because of this Y table, we can do plotting. Okay, as I said, Y table is good for plotting, right? In the beginning, I said, right? The long table is good for storage. Y table is good for plotting or good for doing analysis, right? Once I have that, maybe I wait 10 seconds. So what I do with this index is on the left-hand side, right? This one. The right-hand side is the columns. So that's why I put and the value I put is the thing that put in the square, right? So this is the row, this is the column, and this is the value what I put in the cell. Is that clear? The same as the pivot table if you ever do Excel, right? You have to tell me what the rows, what the columns, and what the value, right? Is that here clear? Index is the row, columns are the column, right? And the values are the value that you put inside the pivot table. Okay. Then once I get that, then we can draw a plotting, okay, and then a stat table. So this is the one that is very similar to what we have seen, but this is the diagram here. Okay, I think I swapped the small and large, but that would be something that what we have, right? We see the small one have this one and large have that one, right? So that's the table we want to draw. Is that okay? But let me wait one minute and make sure that you are okay with the drawing, and then you can ask me if you don't understand which part of the code, or you can have fun. If you have drawn it, you can change some of the code and see if you understand what's going on, right? The good thing about programming, probably you know, is you can play around with the true and false, and change things, and then you will see what's going on. Is that okay? And just slow down because there's no hurry to do, but make sure you understand, right? Is that okay? Okay. I hope this diagram is useful, right? We will do some scatter plot here, but let's do it afterward. But we do a scatter plot. But this is the plot that you would generate to convince your boss, right? This is the graph. You can imagine that this need not be large, medium, small, right? Can be different city. How much they spend, you can group them. Then it's a very nice diagram to draw. Right? The stack diagram is very useful, right? Not just in terms of this. It can be your IT manager. You always do this, right? Okay. Now we are going to do two things. It's called the scatter plot and the bin scatter plot. Okay. You will see, but the first one is the scatter plot you learn in the undergraduate. The bin scatter is basically I don't do the scatter plot, but I collect them together, different bins, and draw a scatter plot. So group the scatter plot. Okay. And we'll make it clear what's going on here, but slowly. Okay. The first one is this scatter plot, right? Look at the management score and firm size, right? So when you plot it, then in some sense, it's not that clear, right? It's not that clear how they're related, right? Compared to the graph we have seen. This is not so clear, right? It's not very clear that actually it's still increasing or a line there or go down. It's not that clear, right? So that's why scatter plot is very useful, but sometimes it's not fully useful, right? It's not like I can see it clearly, right? From this picture, can you see they're related positively? Probably not, right? This is different from the case where, if remember, when we look at this guy, this is where clear is increasing, right? But the scatter plot actually doesn't. Okay, why is the case? Because this raw data is not grouped, so that's why we need to group it and then try to make it look nicer. Okay, but this is the scatter plot. We're going to do is matplotlib dot scatter, right? Because remember, dot hist is histogram, right? So dot scatter with the scatter plot. Okay, so let's plot it. We should be seeing this scatter plot. This should be same as the one you see there. It's like, doesn't seem to be something, but you can somehow say very big firm has very big score, how much higher, but it seems less variance, but doesn't tell you more stuff, okay? But this is the scatter plot. I stop here for 10 seconds. You can try to understand the code, but the main code, the main part of the code, different from before, is this guy, okay? Scatter, right? Because nothing new here. Of course, we have another one, y, because x and y, right? But if you remember what we have done, here is dot hist, right? Everything is the same except this line, right? Except this line. We change this line to this one, right? And this gives us the scatter plot. Is that okay? Now, once we have that, and then we can do more, right? As I said, this is not clear enough to show they're related, okay? So the next step is group them together. Okay, this is a very standard technique when you look at the data, right? You try to show they're related, and the raw data doesn't seem to be clear enough. You group them in different groups and then try to show how they're related, okay? So that is the goal today. Sorry, goal of this part. What we do is, there are many ways to do it, okay? We can do it in 3 groups, but the book suggests we do it in 10 different subgroups first. Instead of going to 10, going to 3, go to 10, okay? And do a 3 scatter plot. And we make sure that each bin is equally divided, okay? Same number of observations in each group, okay? We have 10 groups. And remember, we have, I think, 300 firms. Maybe that means that each bin we have 30 firms, okay? 30 firm, 30 firm, 30 firm, 30 firm, 30 firm, okay? So then that is the goal. Now, if you look at the diagram, we'll do later. Instead of here, we have this one. Is that more clear now? It's increasing, right? Compared to the raw one. This one seems to be suggesting is increasing, right? It's, at least this is increasing, right? So that's why this is useful, right? Instead of telling the plot everything on the table, you have to group them, okay? So the moral of this exercise is telling you that as an IT manager, often you have so much data, okay? Then you have to find a clever way to group them, right? If you want to scatter plot, you may want to group them in 10 bins or more bins, or you want to draw a histogram, sorry, the stack bar we have done, right? Then will helpful to illustrate your main point, right? So we'll try to do that as well. So what we're going to do is we will use the function called qcut, quantile cut. Okay? We use quantile cut, qcut to cut in 10 pieces, and each make sure each bin will be equal. So that's qcut. Okay, because quantile is 10%, 10%, 10%, 10%, 10%. Okay, that's what the qcut. Okay, and then summary we would try to do is we would try to look at only 2 columns, right? Employment size and the 10 bin that we create, okay? And group by them, I look at the data, mean, max, mean, median, okay, so on and so forth. But let's try to do this thing first, and then you see what we're doing, okay? Let's try to do this 10 cut. Let's run one by one, and then you see what's going on. Let's do this, and dot head. Okay. And go to this, okay? It will tell you it belongs to which group, right? You divide 10 groups, so that this we're telling you that you divide into each group. You see the last group is 2,000 to 5,000. Okay, you divide to 10 quantile, okay, to tell you which group you're in. Okay, and what we want is to look at the summary group by each group and calculate this summary data, okay, and see what we have here. Okay, you can see that they divide into 10 different beans, right? And mean, max, median, size, right? Not exactly the same, but they try to do that, but they can't do exactly. But more or less the same number of observation here. Is that okay? And you can see they complain because they said this function is like kind of going to be not working. They try to change it, but anyway, it should still work. Doesn't matter. Okay. Now, is that okay for this one? Okay. The next one we are trying to do is to remember the name of the name of this looks crazy, doesn't seem to be reasonably understood, right? So what we're going to do in the code, what we do is to replace the range by the mean of that number, okay? So that's why I would look at the mean and replace it, right? So basically what I do is, there's a mean here, mean of this group, right? I put this name into here. I no longer call this thing, but I use the mean. So this is what it did, and to dig is to make it to the convert to the form that it can be done. Okay, the dictionary type. So you can see if I run this, then you will see what it's still doing to do. Okay. So you can look at the last column. Instead of the range, you replace by the average, right? Which is this guy. If you still remember, is replace this guy with this guy. Okay, so it's here. Okay, so this is the code that they do to replace the number, and then of course we can do this again. Okay. Okay, we can look at the summary. Okay, this is the table that you want to export. Okay, this is a table. I think I'm missing this last line. Okay, so this is the same thing, but now we replace this with all the mean. Okay, let me stop a little bit before you know what I'm doing. Is that okay? I know a little bit fast here, but I don't want to be too slow. Hopefully this is a optimal speed. It's very hard to tell, right? Whether I'm too fast or too slow. Try to, but is that okay? That's fine. Okay. So now what remain is I do the same thing, but now everything is become a 10 beans, right? This is the same as what we have seen for the 3 beans, right? Same, aggregate this mean and calculate the average score, right? So this is what we do, right? Just focus on the 10 groups and look at the mean of each group, right? So you should see the right, will be this, right? Each group, the mean and the score, right? Then we're ready to plot the data. We're ready to do it, right? Because with 10 data point, we have all the mean for the group for the employment size, and also have the mean of the management score. All right, we're done, right? We can plot it. How to do scatter plot? That is pretty easy, right? Same thing. X is what, Y is what, dot scatter, right? So there's nothing dip here, but let me plot it, then we stop for 3 minutes. This is the graph we've seen. So this is the graph, right? So we now show you how to group the data and plot the graph, and you can convince your boss, right? I mean, right? Suppose this is a number, then you want to do something, right? Because you can imagine this is data. This is maybe this age group. This is how much they spend. Then you can want to say focus on which particular group to target your marketing program, or what kind of thing you want to do, right? So on and so forth, right? You can imagine this data. The technique is highly transferable. Okay. Let's see if you have any question before we continue, right? But do remember what we have done. You have data. You want to show relationship. We can set up. You can have a stack bar, right? After you go to group mean, a stack bar, and you go like a scatter plot doesn't work. So we have to make an extra effort to group the data, to draw the scatter plot again. Then now we are convinced that actually it is a growing up, right? So that is what we mean by descriptive statistics, right? We are removing the dust from the antique we drawn on the ground, right? And so actually what is inside, right? There's nothing new added here, right? There's no new information, but we summarize what had been there. There's no new knowledge being generated, right? It's just removing the dust and we see more clearly, right? So there's not creating news. We're not generating new knowledge, but rather we clean up, make things more visible. Okay. Is that okay? So you can see some good association for the big firm, but medium and it's not that much. Okay. So you see again, look at the graph we have, right? This is pretty strong, but this is a little bit weak, right? This is a little bit flat, right? And this is up, but this is flat and up again, right? So that's what we're trying to say. Okay. And you can also draw the box plot and violin plot. Okay. And how do we do that? Not surprisingly, we're going to go back to the three beans we have done already, the three beans, right? This is we have done already. Right? We're not going to redo that. This is already have that, right? This is the first three line, you already have that, okay? The only difference is here you can see we are smarter this time. We just say small, less than 200, 200 and 1,000, we put medium, and more than 1,000, we put large, right? And then we define this categorical, okay? And so forth. And then we can do a box plot, okay? And here we have to do a little bit more complicated box plot syntax, okay? Because we're actually drawing multiple box plot, okay? So we have to define axis, okay, is the row, okay, which set I have means and management, okay, and then I have to set the label and then plot, okay. So this is a little bit slightly more complicated, okay. It's not just plot because I need to plot multiple things. What I'm doing here is let me show the diagram. What we want to draw is like this, right? Because I want a not just one box plot. I want multiple. Okay, I will define the axis first. Okay, so that's why we need to define a little bit more complicated way to draw it. Okay, a box plot and what's x and what's y, right? Because if you don't have this, that's management score is fine, right? But now we have to do a two dimensional graph. So that would be, I think it should work. Okay, so this is the box plot. Okay, will be same as what we have seen, but I have 1, 2, 3. But anyway, you know what's going on there, right? So you can actually show the box plot, also show the trend. So you can either do a box plot, you can do a scatter plot, or you can do the bar chart, right? There are the three main ways to show how things are related, okay? Is that okay? I think this a little bit complicated is because of this guy, okay? You define it and set again. Actually, I divide it in two parts, but I mean, you can, if you don't like, you can do that. I think that should be fine. You can do the same thing. But usually I would have two lines, right? I define the data, tell them what's X, Y, and Y, and then I do it. Okay, so so that would be somewhat slightly little bit more complicated, but shouldn't be too bad. Is that okay? I hope that's okay. I mean, some of you keep smiling, so I'm not sure whether it's too fast or too slow or too difficult. I mean, it's unclear to me. I mean, today I'm not so sure, but is that okay? I mean, just walk around. Is that okay? You enjoy it, right? That's good. I think many of you are better than I do. I mean, doing a very much nicer diagram than I have been here, but is that okay? Good. So violin plot will be the same. Okay. I think you have the violin plot. Is it typo? I guess a typo. I think there's a typo here. Is it? Let me see. I think we have the violin plot. Oh, sorry, it should be a violin plot. So if to the right. And those of you who see this color doesn't seem to be right because I didn't run this code. Okay, if I run this code, then it becomes categorical variable. The good thing is if I run this, then the C bond will able to say they are. They didn't. Usually, if you do that, they're able to do it, but I don't know why it's not the case. But you can see there's a violin plot to be violin. I don't know why. This should be violin here. I'm sorry for a typo. You should add a violin plot. First plot, you get the violin here. Okay. But to be honest, I never see violin plot in any actual thing. But most of the time I only see box plot. But I guess I may be too old. But you can decide which one would fit your because the violin plot is the same as box plot, but they also show how the data where it is, right? So it's up to you what to use. But I think the box plot is more traditional, so I would usually stick to the box plot because I can see where the median they are, right? Where location is the maximum, the mean, but it's up to you which one you feel more convenient. But for me, I would say for this data, I would prefer the stack bar or the bin scatter plot. That actually I think is best to show the correlation. But if you want to show more data than box plot, it might be the something that will show more complete picture. But I would usually simplify the graph to show the bin scatter. Okay. Is that okay? Now we come to the very last part, okay, is we need to quantify how they're related, right? Probably you will know that in undergrad. That is called correlation and covariance, right? Eventually, right? Some of you are waiting for this for a long time because why I don't talk about this at the beginning, right? Why I talk about all the graph, but anyway, we come back now, okay? It's the covariance and correlation, right? I think I don't need to explain this because undergrad concept, but just try to make sure everyone is on the same page. What's covariance? Is this particular item divided by n. And what's this item? This item is two products. One is how x different from the mean, how y different mean, right? What's measuring is if it's positive, it means that both terms are above the mean all the time or below the mean all the time, right? Because let me draw a diagram. to make sure that you understand that, but I think it's too elementary, but anyway. So you can have a, maybe I should be more careful, right? Let me erase it. Let me do that. Okay. And let me have the color blue. Okay. This is X. And this is Y, right? And then maybe theta point here. Okay. So what we're going to do is to explain the meaning of this covariance concept. I mean, it's very elementary, but anyway. So this line represent what? This line represent average of X, right? So look at all the location, X bar is the middle, right? Is the distance to the left, sum of all distance to the left, same as all distance to the right. This is the meaning of mean, right? The distance from the left and the right the same, right? Just at the center, that's the meaning of mean, right? And same as the Y bar, right? Y bar will be something like somewhat here, right? And the location is exactly where the distance, all the distance here, same as all the distance below, right? That's the meaning of the Y bar. Now, the covariance, what it's doing is looking at this distance, where I use maybe I should use the color deep blue, right? This distance, right, is xi minus x bar, which is positive, right? Because you're on the right-hand side, right? And look at the red one, this guy, right, is yi minus y bar, right? When they're all above these two numbers are positive, right? And they multiply positive, right? So whenever any data is in this region, positive, because positive times positive, positive. When in this region, both numbers are both negative, right? Because this number is negative, right? Y minus y bar, negative, because y bar is higher. And this number is also negative. So negative times negative is positive, right? So whenever you are in these two regions, it's negative. Use a little bit thinking, 10 seconds, you can understand these are negative. Convince yourself. Why? Okay. Suppose this number here, right? You look at this is negative, right? Because this minus this is negative, right? And this guy is positive above the mean, right? So it's not the right side, the negative, right? So covariance is measuring how likely that when x above the mean, y is above the mean, and y is below the mean, x above below the mean. Whether they go above the mean at the same time together or below the mean same time together, or in the opposite direction. If negative, they are on the other side, right? So that is the meaning of covariance, right? I think you learned it in the undergrad for sure, if you learn statistics class, but I'm not sure that you still remember, but hopefully looking at the graph, you would remind you this is the case, right? And you probably remember covariance meaning, then you ask why we have this. This is a very useful correlation coefficient, and it's a normalization. You divide by standard deviation. Why? Because once you do that, it must be between it must be between -1 to 1. 1 is a straight line, positive. -1 is negative straight line, right? And why is the case? You can use involve Cauchy-Schwarz inequality or what the math can prove it. But that is very useful because it's between 1 and -1, right? So, and for Python, if you use the stat package, covariance is there. Okay, and I think they give the sample one, so that's what they have. I'm not going to copy this code. Maybe I should. Okay, make sure I convince you this is the right code. Okay, and you run it. You give the covariance. covariance coefficient, then it's a covariance. Okay, for covariance coefficient is 0.9999, right? So it's not surprising because they move together, right? Okay, you can try to copy and have fun, but otherwise, so the other way around is to use the NumPy that have covariance and correlation coefficient. The reason why I have U01 here is because they give the table and the correlation matrix, you don't need the diagonal, you just need only one or two numbers there. Anyway, let me convince you, let me do it slowly. Let me don't use the 01 and then you tell you what's going on. Then you will see what I'm doing here. Okay. Sorry. So you will see when I do this, they actually give me the covariance matrix, where by statistics, this is the variance, and this is covariance. So this is x and y. The matrix give me this variance of x, variance of y, this covariance. So that's why I need 01, which means I get this one. Okay? Is that okay? So there's a give this covariance a covariance matrix. Okay? If you learn statistics, you know why we need that. But since not stat class, I'm not explaining. So what it gives is this is variance of x, this variance y, this covariance x, y, covariance x, y. Okay? And only we need this guy or this guy. So either you have a bracket 01 or bracket 10, the same thing. You can put 10, we will give you same thing. I'm not 1910. We'll give you 3.2 or 01. We'll give you 3.2 because we only need the diagonal, off diagonal. Okay. And when your bias true or false, whether your sample or population one. Okay, it's divided. The one you divide by n is the population one. Divided by n minus 1 is the sample one. For our purpose, always use the sample one. Okay, because they will have a nice property that we want an unbiased estimate. So you will use this one. But as I said, when you IT manager, you do a big data set, so you can always, there's no difference anyway, because divided by n, divided by n, same thing. Okay, and for this one also a matrix, so that's why you need that one to tell you. So this is the correlation. This is COREF. Okay, the same thing is give you a table. Maybe I should show this one why I need that one. Okay, this is again the same. It's correlation coefficient x and x must be 1 because x and x must be a 45-degree line, right? But x and y will be 977. Is that okay? Is that okay? So what we can do is we can look at this correlation coefficient. Okay, you can do the calculation, but I don't have the code here. We have that actually it's here. So we can calculate this guy. Okay, how they're related. So it's 0.3. Correlation coefficient 0.3. Not very strong, not very weak, but that is this one. Or so you can calculate all the data set. You can do that. But also here, what they do is by industry, they do the same. So it's very simple, right? You can just filter. Each industry can do it, or you can group by and do the same operation. But I'm not going to worry myself. The only thing I want to remember to you is to say you calculate the correlation coefficient, right? Compare this and that one, right? The management score and this guy, right? So you can reverse it, right? If you don't like this code, right, you can do this instead, right? And look at the firm with the management, the same thing, right? Because the same number, right? So it's 0.3, not very strong, not very weak, but there's something here, okay? And 0.3 usually we say is weak, but there's some positive one. Is that okay? So here the rest we'll do is somewhat looks like crazy exercise. Is because the data is stored in SICs, the Standard Industry Classification Code. So it's by number. And here is what try to clean up the thing is this a number represent which industry. Say 37 means auto. This between 35 and 37 is electronics, so on and so forth. So that's to clean up the number, right? So there's nothing new, right? Just replacing the number there. I think you should know what's going on there, right? Just name this guy, okay? Okay, you rename this. If you still not sure what you're doing here, okay? Okay, you basically define the industry at this one, okay? All right, basically you are going to define a new column based on the criteria, okay? If this is satisfied this, you call it this guy, okay? So this is another way to define the variable, okay? You can see, I don't know why the book would use many different ways to write it. Probably the reason is they hire different RA to do it. So you can see the different way to do it. You can use M.Phil, right? There's a many way to generate this, right? But I don't know why sometimes they use this and like that. I mean, don't ask me. I just copy the code from the book, right? And clean it up somehow. So and what they do again is look at this one is value count. You have seen it. It's just like count by industry, right? So there's nothing deep in this line. They're trying to tell us how many firms in this industry, which is the last column we have seen. And the very last is the correlation by group. So you group by industry and do the correlation, okay? And I only want to export the very last column, right? So that is what it's doing, because I don't want the whole table. I just want the thing that we need for our purpose. So that is the meaning, because that is what this line is about. This is trying to get the thing that we want to have. It's from first row to third row. It's complaining for no reason, but anyway, let's. What's wrong with this one? I'll check out why it's wrong. Okay, I'll check out this. I'll tell you next time. I don't want I don't want to spend time checking, but you can do the correlation, should be no problem. But I'll check out. I don't know, doesn't work. But this should be able to generate this guy. I'll figure that out, why it doesn't work, but I'll try to figure that out. Okay, I'm so sorry about that. But basically what you do is just try to draw this diagram. I don't know why it doesn't work, but maybe there's some typo, but I don't want to spend time on debugging, but I make sure that next time I update the slide, it will work. So at least now, just to see that we see the covariance is non-zero, right? Some association. The question is, can we say causality? As I mentioned many times, is not. We need a lot of stuff to establish causality. And if it's experiment, yes. If not, then you have to do many things to make sure that X actually causes Y, but not Y causes X, right? In this particular case, I can't really say whether the firm size lead to with better management score or other way around. But imagine that with data over many years, right? You see the same firm, and initially is a small firm with a good management score, and it becomes bigger and bigger and bigger, right? Then we can say some of the influence can be drawn, right? And if a big firm has a low management score, they become smaller and smaller and smaller, then by this observation, we can say is the management score drive the firm size, right? The other way, we can see a big firm, okay, that has a low score, and at the end, many years the score go up, go up, go up. Then we can say the firm actually drawn that. So the time dimension is useful to discover the causality, right? Or the other way around is maybe usually we talk about policy changes or exogenous changes. There may be something new law that's saying that if you hire enough people, then you have some tax benefit, right? In that case, firms just suddenly hire more, right? And then after that, the actually management score goes up, right? Across all the firm, then actually you would say firm size leads to the better management score, right? Or other way around, if the government provides some bonus for good management score, right? And suddenly after that happened, firm getting bigger, then you would say the score drives the firm size. So you have to rely on some more knowledge to establish causality, but that will be discussed later, okay? But at least the first step, we have correlation, and we know how to do it. We have a correlation coefficient. We can draw different diagram, okay? So I hope that would be cool, okay? Is that okay? And now we're done with all, we don't do all the technical thing, right? So we're happy, all right? So we are done with the chapter 3 and 4. So after the break, we come back, lesson 3. You expect the quiz one will be ready on Friday, right? So Friday, after I teach the other class, I will release the quiz one. Okay? So yeah. So let's a break of say 10 to 15 minutes, 10 minutes, 12 minutes time, right? We'll do another break number 2. If you want to do, otherwise have some break. Okay. So we'll do the chapter 3, sorry, topic 3 after the break. Or you can fill in and let me know whether I'm too fast or too slow or what, but yeah, we get something. Yeah, monkey outside. Yeah, monkey outside. Some people taking pictures. You want to take a monkey. OK， 啊，对，没事，对，thank you，thanks。哦，都是 quiz 做的，我看的。
就是相当于不是当
就是做掉啊，那就是回家做。
配合的时候，还以为是随堂小。
No，没事，就是这个就做的。
就是这种代码，就是要我要记一下。
我们不的，我记是。我们不。
那相当于是我要写在纸上面的。
你是说的 assignment 是啊，我就 assignment OK，assignment 我也你做过，你在这里写就好。assignment 大概就是你大概就这样写了。啊，对，分不管，其实不 open 我的 iPad。对，你可以 print whatever you like。对，so that's。No need， 因为现在太先进了这个电脑，所以必须有点不能带电脑，要不然被 AI 一扫就。
就是可以用 iPad， 也不可以。
print 可以 print whatever， print 都用纸的，因为 iPad 的话 scan 啊有问题。带 paper any paper any number of papers no need。That's joking。换头纸。诶，有照片，有图有真相，还有 video，有好真有好纸，没有骗人的。我看到亲眼看到，不是 AI 的。他不的猴子的找那个朋友的猴子。哦，看到了，看了照片。不会的，我会的，有人就是写猴子的，应该是会想，不然你上会在里边活动。你们自己不晓得什么的吗？有学生群没有？没有大群吗？在这个发了大群上面去吗？IT 或群上面去没有啊？就发一个人，大家都有机会看到猴子，没有来的也可以看到猴子。我在 B.A 那都没有机会看猴子。 在 B.B.A 在 CYT 跟 CYT 做的是 finance 的话，必须的。我刚才看见有微信，哎，我刚才派的，因为我的猴子，我跟他吵，可以。看到了吧？哎，很好，很好。那我看到猴子。还有权益发说，你看到？对呀，对呀，不好解释。你好，你好。我马lau精係，但是非相關，高度相關，不會是相關。80年代。即係好似啦，而家所講好似香港買緊，聽得到佢買嘢，亦都係個。如果你們可以去一個千萬國寺，萬國寺有野豬。不會有人很好玩，下棋都有。所以野豬一家大小。Maybe we can look at how your response before continue. I don't know how fast for the first two setup. Okay. I thought someone would say monkey, but no. Yeah, Matplotlib is very convenient and turn out to be this is the drawing library that you would draw when you draw based on data. So basically, this is everyone would base on that. Yeah, that's good. Okay, speed is okay, not too slow. Yeah, I think it's okay. So far, it's okay. Which program we recommend a Master of Science Statistics? I suppose you mean computer programming. Recommend. Do you mean this or this? I think what you meant, right? You want to study Master of Statistics or Information Science Management? I think Information Science is better since you're ITM, right? You choose by what you're doing, but the thing is, like statistics might be too technical to be useful, right? Unless you're very technical enough to apply, right? So I would say the information science is better. because you just apply. So depend on different type of job, right? Whether you are data scientist or data analyst, right? So whether you want to say machine learning, maybe you want to call the library and do the things, or you want to design the algorithm to do things. It's like different type of job. Of course, to be as an economist, I would say depend on your well, that is the economist said, right? Is everything is depend on your skill set, right? If you're math oriented, you know you like skills and you like how to crack those things. Of course, master science statistics may be better, right? Because you know how to crack stuff. But you like some soft thing, you able to analyze, you want to aim high, earn more money, maybe the information science is better, right? Because look at all the CEO these days, right? Are they engineer? No. Are they good engineer? No. But they're MBA student, they're management guys, and then how to make money, right? It's just like that is better, right? It really depends on which one you think you can do better, right? So it's really hard to say without knowing what the type you are. But if I don't know what your type, then I would recommend the second round, right? It's easier, right? That's like if someone asks me, undergrad, do you want to do business school student or you want to do a engineering student, right? Unless you like engineering, then I would recommend you to do business school, right? It's it's easier route, and then if you're smart enough, then you make more money, right? If on average they make the same amount of money, right? So but of course, if you don't like to talk to people, you just want to crunch number, do some software, you're a geek, then probably you want to be engineer, right? So this really depends. I mean, hard to say, but that's my recommendation. Oh, how can I add more Q animal? Yes. Q animal, tools, setting, miscellaneous. I want crab, then I just add crab. They disappear. Wait a bit, the crab should come. Wait, the crab. Yeah, the crab is coming. Okay, so that's how I do that. Okay, and one thing that I thanks for one of the audience that tell me that what's the error in the code I have is I missed the green square bracket for some reason, and once I do that, I have this correlation matrix. Okay, and because I only want this thing, I don't want the whole matrix, so that's why when I add this guy will left me what I want. So just if I run this, it will get me the number that I want. Okay, so I just forget the square bracket here. Thanks for the nice audience that will do the debugging for me, but somehow I forgot to do that. Maybe you can add them back. That would be the missing square bracket, which is here. I forgot the square bracket. I don't know why I miss it, but anyway. So that would be the case. So basically, I owe you nothing at this moment. Maybe I owe you the assignment after the class 2, so that's fine. Okay, so if there's no further question, let's jump to lesson 3. So I'm sorry that lesson 3, but we only start lesson 3 here, but it's okay. It's okay to fall behind schedule. As long as you get everything right, we just cut some corner here and there, but as long as you understand what's going on. So if there are no question, I guess the case. We would try to give you the foundation that we will run regression and we will do more things. Okay. Oh, there's some regression on the table. Yeah, regression here. Surprisingly, it's not my writing, but probably you know, right? We want x cos y. There's a z there. Anyway, I want to run the regression. This is a regression, right? At the end, this is something we want to do. I think chapter 7 and 8. I think I'm right. 7 and 8 stuff like this, right? If I remember. Yeah, the class with after that, if you want to try to do that, right? What regression is doing is jump ahead a little bit, is what regression is doing is like this. Okay. I have a scatter plot like this. I want to find a line here. Okay. The line represented by this equation. Y equal to beta 0 plus beta 1, x equal to epsilon. And beta 0 is the intercept, beta 1 is slope, right? And once I run the regression, okay, I got number, maybe slope is 1, the slope is, say, 5, say, suppose, right? But the main thing we want to do is want to make sure this number 1 or 5 actually is meaningful, right? By meaningful means that it's not by chance we get this positive number, right? So we want to what we call hypothesis testing, okay? The t-test, this is something we want to do today, okay? Why I want to learn this is because after we run the regression or after we have a model, we want to make sure the model estimated is meaningful. How to do that is we have to test the hypothesis. We have to something to test. We have to data to see whether this thing is not by chance. Okay, so that's the goal of today's chapter, which we cover next week as well, is hypothesis testing. Okay. And the next thing is generalizing from data. Okay, is idea is to give the general knowledge that we are generally new knowledge, right? So far, we have done is look at correlation, look at mean, variance, those kind of things. Nothing created from the data. We just tell that what data is. But we want to say what the data tell us actually can be generalized to bigger picture, right? Just we only have a snapshot of what we want to study. But we want to say this would apply to the thing we want to say, right? Suppose I want to look at the data of the IT system. We'll look at a one snapshot of today, right? Look at today's data, right? And then I want to draw a conclusion on tomorrow, right? Or even have data of the whole website on the past. What we want to say is the future, right? So that means that I want to generalize from the past to the future. We need something new, right? A new knowledge. If we want to say something in the past, that's fine, right? We want to say carry it to the future. That is go to the domain we don't know. Okay, so that is what we're doing. Okay, so that is what we're doing for the generalization of data. Okay, so that is what is said, generalizing the data, right? Suppose we have the data showing their correlation, right? Is it going to be generalizable? Okay, there are two steps. In most of the textbook, they focus on step 1. Step 2 is not often mentioned, but it's very important as well. So step 1 is saying that, okay, there will be some procedure, is generally accepted procedure. We can extend what we know, okay? It's like procedural things. Like if you do this process, then it's okay, okay? It's well accepted, okay? It's very mechanical. Understand the mathematical symbol, how we operate, maybe it's for master of statistics, but we're just telling you that using this code in the Python, this is what we do, okay? That's one click and you get the result, right? But just like when you ask the AI, right, ChatGPT, or just click, what's this? And outcome comes out as a black box, okay? You just know which black box to use, okay? This is one thing we do. But the second part is very important. Remember, garbage in, garbage out, right? So that means that once we run the nice analysis, right, machine learning model or regression model, we have predict what's going on, but we have to know we extend say in the past to the future, right? The question is the past a useful indicator of the future? Right? Is it going to the future same as today or not? Right? And sometimes yes, sometimes no. Sometimes maybe no change is fine, right? But things can change. Look at the stock market, say, to be simple, right? People would think the economy will go up and down, up and down, up and down, right? Down and up, then it's normal, right? But after COVID, right, everything changed, right? That's new normal, right? Things change. Now we have some fundamental change of the economy, right? So the central bank of our country is going to print, right? Infinite printing. So things become different, right? Is the stock market will remain at below 3,000, or they defending 2,800 or 2,400? I don't know. But if as economists, I think print, then we go to 5,000, go to the sky, right? Go to the moon if they keep printing. But anyway, that is a problem, whether you will want to see whether it's still valid or not, right? Or for example, you think about online marketplace, you are working for JD.com, say, for example. Is it tomorrow same as today or last month? Now the main changes is I think Walmart is going to get away from JD, right? He sell all the shares. It's going to same or not? Right? Is it going to be different? Okay, so these kind of things will change. Is it going to pass or part of the future? Right? Or I look at, say, now Taobao, right? They no longer use Sunfeng, right? In Hong Kong, right? They use Cainiao, right? In Hong Kong. So things change, right? Is it going to change the customer satisfaction? Right? Those kind of things you can see, right? Because things will change. Whether external reality is an issue, right? Because you collect the data and it's data generalized. Is the data representative? If not, you cannot generalize this, right? So that's why it's garbage in, garbage out. So make sure that your data is fine, you can generalize it. Okay. And say, for example, your data collected based on coastal area, okay, coastal city, will apply to the rural area or not, right? Or you get the data from Shanghai, is it going to apply to Beijing? Is it going to apply to Shenzhen? Is it going to apply to Hong Kong? I don't know, right? But very often we do a lot of generalization easily without careful, right? Very often we don't look at the internet, right? Some heartbroken lady say all men are bad, all men are disloyal, right? Then why? Generalize, right? She may be unlucky, have several men that cheat her, right? He generalized to every single man, right? Which might be true or maybe not be true, but this is too quick to generalize. But anyway, that is the idea. Okay, how can you generalize it? Anyway, so we'll talk about generalize means that one thing to do is to estimation, or what we call prediction. Okay. So how can we do estimation? Is we want to pick something we want to estimate, right? Suppose the data, we want to study, say, how much people want to spend on our product, or how much time they want to spend on our website, right? The traffic, right? So what we do is to collect some data, we collect some set of the customer or in the past or someday, then you form the mean or from the variance, right? Because this is something, the character of the data, right? So you want to guess what was the population mean and population variance, right? You want to guess in the future how many customers would come and stay in the website, right? How variance of this, right? These are all the first two things. That's the most useful thing you want to do, right? Pick one. And you want to use the data to give a guide what are those numbers, right? So that's why actually we learn the sample mean and sample variance are guessing the population mean and population variance. Okay. And by sample, actually, you have to adjust M-1, those kind of stuff, right? Or M-2. And next is beyond point estimate. We also want how accurate it is, that's interval estimate. Okay, that is you guess that, but not just one point, but guess a bunch of points. So that would be the goal. So let me repeat what we're doing. It's a little bit abstract. Okay. The idea. Let me give example to. Do I have example here? Later it's stock price, but let me take example that is in IT, right? Suppose the question is I want to say estimate what is the traffic for, say, suppose you work for the IT, right? Now you work for IT department for, say, Alibaba, right? It will soon be November 11, which is a big day for the e-marketplace, right? Because a lot of sales going on, right? Then you prepare the bandwidth because then many traffic will comes in, right? Then what are you going to do? How the boss asks you what is your how much the bandwidth you should prepare, right? Because the bigger is more expensive, right? You have to give him some idea. What we do is look at last year, right? Hopefully last year is a good estimate of this year's, right? And then what you're going to do is maybe look at last year, November 11, right? There are many traffic during the whole day, right? You can look at the mean, which you care, right? Look at the mean of that day, right? Then look at this year's November 11th. What's the mean, right? Look at the variance, because the variance tell us how variance is it, and then you can calculate upper bound, lower bound, right? Assuming normal, then you have 2SD minus 2SD will be the upper limit and lower limit, right? And this will be sufficient for the manager to do decision, right? So you get the mean, you get the variance, then will give the manager to say, manager maybe you, right? I mean, you have decide how much bandwidth you should reserve, right? And the first thing to do is look at the point estimate, right? The point estimate will be just a number, and point estimate for the mean will be just sample mean, right? Point estimate for the variance will be sample variance. That's done, right? But giving us one point is not going to be sufficient, right? Usually we want a range of points to give an estimate, right? Why? Because you don't want to be wrong. Look at the stock market expert, right? Look at the TV, right? They will say, what is you ask in the morning, right? The reporter asks, oh, what's the Hang Seng Index today, right? Let's try. Let's Hang Seng Index, right? So what today we have 19. That's end today, right? Today we have 19,000, right? So maybe suppose a reporter come to me tomorrow morning, ask, okay, what is my guess? Okay, then I would say, right, the best estimate usually would be depend on where go up or go down, right? Maybe my guess would be 19,500, say, or 400, right? Maybe 300, 400 would be a good estimate, right? Okay, I give them a number, but if I give one number, must be wrong. So how can I save myself, right? So I would say, okay, tomorrow will be the Hang Seng Index will be fluctuating between 18,000 to 20,000, right? Then for sure I win, right? I mean, of course, I want to look less, to look more capable. I would reduce the range, right? Maybe 19,000 to 9,500, right? So 500 bandwidth, which is fine. Maybe of course you will get it smaller, right? But you instead of getting 1 point, then you will get interval, right? So the question is how to get the interval. That's the interval estimate. Okay. So that will be the idea. Is that clear? Now what we're going to do is the data focus on is a risk management exercise. Here they look at the investment in the US stock market, which they use as a SP 500 as a proxy, Standard & Poor's 500 stock index. And what's the goal here is unconventional, okay? But it's very normal is I want to invest in US stock market in the risk is not too large. So I want to calculate the probability that my loss is more than 5%. Okay, I invest, I lost 5% in a day, right? So that is something I want to look at. Okay. So what we're going to do is that this data, they give us 11 years of the prices, okay, and from 2006 to 2016, okay. So how to download data? I think this is something not new, okay. The only new line is the third line. Is science library. I use that. And later you will see I want to import normal because a bell curve I want to calculate, but later you will see why we need that. We don't need it right now, but later you will need that. But this is data, we just try to do that. Now we have chapter 5. So if you want to take a look, then let's see what the data is, right? Let's add a little bit. So this data, right, you can see it's just value from the SP500 from each day. Okay, the data is very simple. Just a standard time series data, right? By day and the value. Now, we need to clean the data. So I call a new variable called SP500. Okay? Is I would take things is not there, is not NA. Things called NA is NA. And I drop all the NA. Okay. And then I reset the index. Okay. Because because it's a time series data, so I just reset the index. So let's see this. So, okay, what data do we have? So I reset the index means now I have redo the index because the reason that I need to reset the index is because I dropped something, then the index would jump, right? Because some data is gone, so I have to take away the index and re-index everything. That is a normal operation. You don't have to do it; it doesn't really matter, but do it for the sake of doing it. Okay. Is that okay? So I hope you understand what's going on there. I just replace no value by NA value by NA, and then just drop all the NA. Everything have value now. Okay. And then if that's okay, then we continue. Now, there's some interesting code here because I only care about the return, daily return, which means that I will look at the percentage change each day, right? It's today's price minus yesterday price over yesterday price. That's percentage change. 百分比变化, right? 百分变化. So it's today's price minus today over today's, sorry, today minus yesterday over yesterday, right? So that is stock percentage change. Because percentage I multiply by 100, so everything is in terms of percentage. So that is the idea behind this line. So you can see whenever I try to explain what each line is doing. As IT manager, you should be able to do the same. Okay, for each single line you write, you should be able to explain. Of course, I'm not asking you to do it in your assignment or your exam or project, but you should be able to explain every single line. Okay, why you do this? Now, next is the line that telling you that, okay, this is data, right? From data, you can see 5% is here, then almost nothing happened, right? There's the risk is not very risky, right? You lost 5% in one day, right? And the data actually can check, but I'm not going to do it, but you can check percentage of day is less than 0.5%, so it's very little, right? So you have suppose you have 1,000 days, only have 5 days, right? So maybe okay, right? It's not that bad. Okay. Is it going to be generalizable, right? Is it information going to be useful, right? This is a past. Is it going to tell us anything, right? So how can we generalize this? Okay. And the question like this. There's only, suppose you believe there are multiple universe, right? We only observe one universe, right? As far as I can feel, right? Unless you can feel there's somewhere you are there, right? But I only can feel me in this universe. I can't feel myself in another universe, right? Just like the sampling, right? We only have one pass in the stock market. We don't have multiple pass, right? The question is, we only collect one sample. We don't collect many samples, right? So the problem is it what we collect is maybe by chance we get this result, maybe by chance we don't get the result. How can we make sure that what we get is good? Okay. So there are many ways you can do it, okay? But one way you can think of this is we will derive how good is we can look at the standard deviation of our estimate, okay? So we will get precise later. But this is something we do, is we will find out the standard deviation from the estimate we want to do, right? For example, we want to use the sample mean to estimate population mean, right? We want to know the standard deviation of our sample mean. Okay, that is a standard. That is called the standard error. Okay? We will be more precise, don't worry. Okay. And is super technical here. Which this is the thing we don't prove, but it's very technical. Maybe I should move this to technical slide. This is saying that why sample mean is a good estimate population mean. Okay, that's why I think you learn in the undergrad, right? And say why the example we have is why the traffic in the last year, November 11, would be good estimate of this year, November 11, right? Why that would be a good one. Okay. The thing is, sample mean satisfy three nice property, okay, which is technical, but I just briefly mentioned. Okay. The first one is said is, suppose we have parallel universe. Okay. Each universe do the same as what I do. And suppose you can talk to yourself in other universe, you get all of the sample mean, average them out, what you get is actually the population mean. Okay? So that means that suppose you can do this thing many times, average of all the outcome, that's what we get. Cool. So that's unbiased. But of course, you just do once, but you imagine yourself in different universe, you do the same operation, the same thing would get. So fine. The second one is if the sample size is large enough, okay, and the sample means a bell curve. Okay, when bell curve, then you can do nice thing. Okay. Last one is Wood-end convergence. It's also a technical term, but what it means is very simple. It just means that instead of thinking multiple universe, suppose you are Jack Ma, you have so much money, you keep doing good sampling, okay? Keep collecting sample. The sample size go to infinity, okay? And if you have collect the sample size, then so big, the sample, then what you get, the sample mean has no variance, right? Then you get, what's that? There's nothing deep there. Just like imagine a very simple idea. You have a die, right? 1, 2, 3, 4, 5, 6. Okay. Oh, make it easier. You have a coin. Okay. You don't know it's fair or not fair. Okay. Toss a coin. Okay. Toss a coin many times. Okay. Maybe 10 times. Maybe out of that, 5 times is head, 5 times tail, right? In case they said 1/2, right? Then if you toss 1 million times, then maybe roughly half and half, right? But if you have 1 billion times, 1 billion times, then if the coin is fair, then half of them, very close to half of them, is head, half of them is tail. So that means that if you increase the sample size larger and larger, then there's no uncertainty. If for sure that is always right. Right. So that's the idea, right? Just like if you try to look at the data in China, suppose I want to collect the sample of some city, right? If you have a sample of 1,000, then possibly you have a lot of variance. Depends on what people you talk to, right? But you have money to talk to everyone in the city, then there's no uncertainty, right? Then you get very close, right? So that is a meaning. But anyway, I should leave you a technical slide. So here is what we want to do. Oh, sorry, I should stop here. But last slide. Okay, sorry, I should run. Is you can do it, okay? But one way to do it that's beyond the undergraduate statistic is do simulation. That's very common because of computer science. You're a computer manager, sorry, IT manager. You're able to know what we call the multi-kernel simulation. So we just pretend ourselves in the history, okay? And we, based on the data, we create multiple universe. And based on this, you create the universe. You can do the sample, mean and you can do the data, pretending those are history. You can calculate what may be the data. Okay? To put it more concrete, your data of November 11 last year, right? Your many customer comes in and so on and so forth, right? We've got 10 million there. So what we're going to do is you grab some customer there, okay? Try to collect them, generate some new fake customer there, create different data set, right? And calculate mean of this similar data set. Then you can calculate how accurate the data is. Okay? Just you create the parallel universe by the computer. Okay, you can see how accurate the data is, right? Because by many universe, you can see the sample mean how it dispute look like, right? But don't worry, we'll talk about this method in the next class. So see you next time. Then happy National Day. Okay. You may enjoy the hiking if you go to there. And the seafood.